The ribbon machine produces glass envelopes for the manufacture of electric lamps, numerous valve types, Christmas decorations, bulbs for the car and other domestic industries. Various size machines produce these at speeds varying from 300 to 1,000 per minute. In order to explain the operation of the ribbon machine, let us look at the 3.9-inch pitch machine, which produces the large bulbs at slower speeds. From this view, one can see the stream of glass enter the machine on the left of the picture. The chain carrying the blowing tips is moving along the top half of the machine in an anti-clockwise direction, whilst the mold carrier chain is moving in a clockwise direction in the lower half of the machine. The ribbon of glass is carried on orifice plates in the center of the machine, being joined by the tips and the molds at various stages to produce the bulb. Now to look at this in detail. A stream of molten glass leaves the furnace forehearth and enters two rolls, one being a pocket roll and the other having a plain surface. The glass is rolled into a ribbon with pockets of glass at regular intervals, each pocket locating with an orifice in the plate. Looking at the reverse side of the machine and underneath, we can see the ribbon of glass falling onto these orifice plates, which are moving horizontally around the machine on a guide rail. Whilst coming back to the front view of the machine, the blowing tips move along in an anti-clockwise direction, moving down in such a way that each tip locates in a pocket of glass. At this stage, a small puff of air is introduced through the tips to commence the formation of the glass blank. The glass then falls into shape moving along the development area, being joined by the mold halves moving upwards in a clockwise direction. When the glass blanks are in an optimum position, a cam operates closing the molds, and at the same time the molds commence to revolve and air is forced in at pressure through the blowing tips. At the end of the carrier, a further cam comes into operation to stop the molds revolving, splits the molds into two halves again, and the blown bulbs now move along the cooling area. They are then knocked off the ribbon. The bulbs are examined, both visually and dimensionally, by quality control methods. They are then packed as clear bulbs, or alternatively, if required as pearl bulbs, they remain on this belt and move on through the frosting plant. In order to process them in the frosting plant, it is necessary to place the bulbs into trays. For this purpose, the traying machine was devised and inserts 100 bulbs into each tray automatically. The trays are received into the underside of the machine, whilst the bulbs roll off the belt through rubber dividers into lanes in the machine. The operators are evenly balancing the number of bulbs in each lane. The bulbs move on along the lanes to be collected by a series of paddles, which move them down and with the aid of air pressure insert them into the trays. From here, the trays move on past a further visual inspection point and into the frosting process. The trays traverse over a series of tanks, each fitted with jets and holding various solutions. The first tank contains a hydrofluoric acid mixture which etches the surface of the bulb. The second and third contain diluted acids which even out the roughened surface, thus strengthening the bulb. The fourth and fifth contain hot water in order to wash away all traces of fluorine, and the sixth, seventh and eighth tanks contain hot air for drying purposes. After being processed, they receive a further visual inspection. In this case, the examination of the underside of the bulb, again by the aid of mirrors. And the bowl of the bulb is examined by the aid of fluorescent tubes. After which, they are now packed as pearl bulbs and dispatched to stores. From here, they proceed by road and rail to the various manufacturers in this and 27 other countries.